My talk will be in English. Thank you, Mr. Chairman. We will talk about deep learning application in coronary segmentation, comparison of three models, CNN3 models. I have no conflict of interest to declare. As you know, as an introduction, X-ray angiography remains the first exam to apply for the diagnosis and treatment of cardiovascular disease. Analyzing X-ray imaging by tracking vascular structure is sometimes difficult because of the complexity of vascular structure, the image noise, the poor contrast type of stenosis. Many methods for blood vessel segmentation have been performed. Recently, deep learning methods have been proposed in a wide range of medical application and outperform traditional methods with better performance. The UNet architecture is the basic, the most modern segmentation methods. So we taste three models that have been successful in many semantic segmentation of medical images. The first one is the UNet system, the second one is the ResNet, and the third one is the dense UNet architecture. Our study proposed three X-ray segmentation models to take advantage of each improved performance. Furthermore, since there is no registry database available for this task, we have our local coronary database set. These are the three models that we taste. You have the UNet model that will be described firstly in 2015. The ResNet model is described for the first time in 2016, and the dense UNet is described in 2017. The first step is pre-processing of coronary artery images. The second step is data augmentation using various methods to improve performance. Finally, we make data augmentation image for the blood vessel segmentation for augmented image using the previous DNL segmentation images. So as experiment setup, the first step we perform a manual segmentation that was done in collaboration with cardiologists and computer science engineering. The initial images are considered as the ground truth. So every image is divided into 5,000 patches, and then data set is split into two data sets, 2/3 for training and 1/3 for validation. For example, here, as you can see, we have the input image. This is the initial image that we analyze. Then we enhance the images by the DNN models. Then we done the data augmentation, and finally, we have the data segmentation. The performance metric, we have four variables. The true positive are pixels representing the blood vessel white colors correctly predicted. The true negative pixel not representing the blood vessel black color correctly predicted, and false positive pixel not representing the blood vessel incorrectly predicted. Finally, the false negative, the pixels representing the blood vessel incorrectly predicted. We calculate the accuracy, the sensitivity of the images, the precision, and the F-score. If the F-score is 1, we have the better system. As a result, coronary artery segmentation was performed 225 images selected for in two-dimension X-ray coronarography. The size of every image is 512 pixels containing 256 gray level and a resolution of 0.3 multiplied by 0.43 millimeters. These images are obtained by coronography using a single plane CMS RTZ angiography system available in our Department of Cardiology, University Hospital of Monastir. Then we applied rotation, flipping, and transformation. And after that, we obtain finally 102 images to analyze. For example, here we have the original image. As you see, the original, the ground truth that made in collaboration with computer science. And as you see, you have the last one with the dense UNet that is predictably is nearer than the ground truth and the initial images. So the dense UNet is the better system to apply for this segmentation. Here we have the result. As you can see, with the dense unit, we have the better accuracy, the better F-score, and the better sensitivity. However, with the unit, the basic one, we have a better precision. For the future perspective, we apply this system now, CNN model in case of total coronary artery occlusion to see the distality, CNN model in multiple coronary artery occlusion, prediction of the evolution of atherosclerotic plaque, and finally in coronary artery bypass graft occlusion. As a conclusion, in our study, we try to compare between method using DNN architecture, the UNET system, the ResNet system, and the dense UNET system in coronary artery segmentation. However, to better refine the coronary artery segmentation task and assist clinician when acute coronary syndrome is diagnosed, we have to work on the utility of patch size to depict different type of coronary lesion. The patch size is to view the lesion in 3 dimensions. So you see the lesion in 3 dimensions. However, this system, you can see this, the segmentation in 2 dimensions. So we have to work on it. And thank you for your attention.